Hello wonderful person, this is Anton, and in today's video I wanted to answer a simple question. How was this beautiful gas giant known as Saturn created, and how were its rings made as well? In today's video we're going to use Universe Sandbox to basically create Saturn from scratch and try to recreate this beautiful gas giant and its moons as well. Welcome to What the Math. And all of this started billions of years ago, specifically about 4.5 billion years ago, when the protoplanetary disk around our sun was still kind of developing and creating all of these planets, including planets like Mercury, Venus, Earth, Jupiter, and of course Saturn, which is right there. And so back then, the actual gas giant was still developing, it was still kind of floating through space. And as it was actually floating through space around our sun, it was collecting all of these dust particles from the protoplanetary disk and basically acquiring them in its own orbit. So a lot of this yellow particles that you see became the blue particles here. This is of course just for the visual representation. And as it basically flew and orbited around the sun, it collected more and more of this dust until essentially we had something that looked like this, possibly even thicker than this, so I'm gonna maybe add a little bit more here. Basically, it was a very, very large planetary disk with a very central sort of region that would become Saturn, and this was basically all of the gas that collected into this one large object, and around it there were quite a lot of various gases and quite a lot of various rocks just orbiting around. With time though, these rocks and these gases started to coalesce into larger and larger objects, and so we're going to represent this by adding a few objects here to basically represent the potential moons that will be orbiting around Saturn in the near future. So there's a few moons there that basically represent larger rocks that coalesced into big pieces that started to basically orbit in various spaces, various regions of space around Saturn. Now with time, all of these objects will start becoming bigger and bigger. They'll actually essentially get rid of all of this dust around Saturn. They'll most likely interact with one another, and they'll most likely crash into one another, or possibly crash into Saturn and essentially erase a lot of this interstellar, or not interstellar, but this planetary particle stuff that is currently orbiting around Saturn. So we're going to wait a little bit, let them interact with one another, and see what happens in a few weeks' time. So right after a few weeks, you'll notice that a lot of this dust will most likely get kicked out, and many of these moons will actually start combining into one another. Now, this process will not actually take very long. As a matter of fact, this will take less than a few million years to basically get rid of most of this material and to combine all of these rocks into large moon-like objects. And these will eventually become satellites. You may have actually just noticed a collision right there. There was a very large collision between two moons that I already missed. I don't know where they are. But basically, a lot of these moons will become proto-satellites and proto-moons of Saturn. Unfortunately, not many of them will actually stay here, not many of them will survive, because as they interact with one another and as they interact with all of these dust particles, they will eventually slow down and crash into Saturn. So most of them will actually not stay here. So millions of years will pass, and we're going to accelerate time here just to kind of simulate this, and most of this stuff will actually be gone. It will either be kicked out into the outer solar system, or combine into the moons of Saturn and then possibly crash into Saturn itself. So the majority of this stuff will very likely just kind of combine into the actual gas giant. And so you may have noticed that there's a lot of particles that are basically being thrown out by the more massive moons, and a lot of various moons are actually combining into one. So we're going to actually see this better when we look at their orbits. So right now, if I actually look from the top here, you'll notice that a lot of these moons are actually interacting with one another at all times. So right here, there's actually two moons that are very, very close, and they might even crash into one another any second. Even though they technically kind of look like the moons orbiting around Earth, they would not look like this in reality, of course. And less than a year later, you can see that a lot of the material has actually already escaped into the outer Saturn system and basically will never come back. And the moons are still kind of changing their orbits, they're interacting with one another, and they're actually slowly losing speed and will eventually crash into Saturn. And the reason they're losing speed is actually because they're interacting with various particles and with one another, and are slowly dragging each other down, basically reducing the orbital velocity. And so for the most part, most of this will be gone within the next few million years, so we're actually going to just erase the particles and leave just the moons. Now let's accelerate time and let's just have them interact with one another until there's basically almost nothing left. Now, most of these moons will combine with Saturn. They'll actually crash into Saturn and they'll become part of it. But there might be some moons that will be left. In reality, we know that it's very likely that only Titan was left from that time, and you can kind of see that just for a second there, Saturn actually lit up and it became very bright. That's because something just crashed into it. One of the moons just crashed into it. But yeah, so only Titan very likely remained from those days back in the beginning of the creation of Saturn, and possibly some of the other larger moons, but there you go again. But definitely not the smaller moons that we currently have orbiting around it. And so we're going to run this for a few years until there's almost nothing left, and until there's just a few large moons remain. So let's just accelerate time here and watch what happens. And just around this time, you notice that there's suddenly all these colors here. That's because something just fragmentized, became fragmented, and basically started orbiting around Saturn instead of being a whole chunk. Now we're still losing some moons, but there's still quite a lot left, so it will take maybe a few more years before we finally lose most of them. So I'm going to just wait a little bit and let the game interact and let the objects crash into each other until there's almost nothing left. And so here we are 60 years or 60 in-game years later, and we've lost quite a lot of these satellites. As the years progress, we'll lose more and more of them will most likely collide with Saturn and completely disappear. So what we'll have at the end is going to look something like this. There's going to be a bunch of moons left in the orbit around Saturn, with Titan somewhere on the outskirts. And Titan here would probably be the largest moon currently available. The other moons would be pretty large as well, but what will happen to them eventually is that they're actually going to crash into Saturn, and this is because there's still a little bit of planetary debris left orbiting around Saturn, and as it orbits around, it's going to slow down all of these objects, and they're slowly going to basically crash. So let's maybe accelerate time just a little bit and pretend that this happened a lot sooner than it would otherwise. So a lot of these moons are basically now going to combine with Saturn and become part of it. So there you go, there are the crashes, with Titan being the last. Now some of the smaller moons will very likely remain in orbit as well, because they wouldn't have as many drag effects from the particles orbiting around Saturn. And so at the end we'll get something that will very likely resemble the Saturn that we know today, with all of the smaller moons present and Titan orbiting right around here as well. There's still one thing missing though, the rings. Where are the rings? Well, as Saturn orbited around the solar system, it started capturing various asteroids, and this is actually what these irregular satellites around Saturn are. Every single one of them is actually a captured asteroid from either the asteroid belt or possibly a comet that approached closer to the Sun. But some of them got to actually orbit around Saturn relatively close, or maybe even passed by really close to Saturn, like within vicinity of its Roche limit, which would essentially destroy these comets. Alright, so these ones are actually going to crash into Saturn, so that didn't work as well as I planned. But let's actually try to launch one this way and see if it actually is going to work. And there you go. So there is Charuklo that passed by, maybe a little bit too fast. We can try this again actually. maybe a little bit slower this time. And there we go, but still not exactly the orbit I was hoping for. So maybe we'll just have to put them in orbit, manually put them in orbit just to see what's going to happen. So if an asteroid approaches Saturn, or really any gas giant relatively close, and this is exactly what happened, they're going to basically disintegrate, as you can see right now, and create the actual rings around Saturn. So with time, it captured quite a lot of various asteroids that essentially we're going to use right now to create a manually made asteroid ring around Saturn, because the Roche limit or the tidal effects of Saturn are going to destroy these asteroids. It's going to completely disintegrate them into little pieces like you see right here. It's going to be little fragments that will eventually become nothing but tiny rings that we're going to be creating right here. And so with time, what happened was that all of these asteroids that Saturn was able to capture, these were mostly containing ices and things like water. All of these basically created the beautiful rings that we have around Saturn today. And so this was essentially how Saturn was created, how all of its moons developed, got swallowed by Saturn with only Titan and a few minor ones surviving, and how its rings got developed as well. And anyway, so hopefully you learned something from this video, and hopefully now you know how Saturn and its moons were made something like 4.5 billion years ago in our solar system. If you've enjoyed watching this video, don't forget to subscribe, and don't forget to share this video with someone who enjoys watching educational videos using video games. And of course, don't forget to come back tomorrow, because there's going to be more videos and more educational content for you. Alright, let's actually halt all velocities and watch all of the stuff crash into Saturn, creating a magnificent superstructure with nothing in the system. And anyway, I'll see you guys in the next video. Space out. See you later. Bye-bye.